All right, back at you with another checkpoint practice. So we are working with solving systems of equations using the elimination method. This first one I picked because it was kind of easy. When you are solving by elimination, you are trying to find your variables that can cancel or eliminate. So you're looking for your x's stacked on top of your x's, your y's stacked on top of your y's, your answer on top of your answer. So that's all set up great. And then the next thing that you're looking for is that your variables have a constant in front of them that is the exact opposite of the other. Okay, or it's called an additive inverse. So here I have negative 4x and positive 4x. So those are going to be my additive inverses. So what I'm going to do is I'm going to add these equations together. The reason that the additive inverses are important is because when I add these together, they're going to eliminate. Okay, negative 4 plus 4 is 0. So these x's are eliminated. Okay, and now I'm going to my y's. Negative 2 plus 8 is 6. And then I have negative 12 and negative 24, which is going to be more negatives, and 36. So now I have just y by myself, and then I can solve it. So 6y divided by 6, whatever I do to one side, I have to do to the other. These 6's are going to cancel and leaves me with y. And then negative 36 divided by 6 is negative 6. So now that I have a y value, I'm not quite done because what I'm solving here is a point on my graph. So I have my y value in my ordered pair, my point, but now I need an x value. So I'm going to take this y equals negative 6 and I'm going to plug it back in. And it can plug into either one of my equations. I'm going to plug it into the top one just because I prefer to multiply by 2 instead of multiplying by 8. So when I plug that back in, this is now going to be negative 4x minus 2y, but instead of y, I'm plugging in that 6. So this is minus 2 times 6 equals negative 12. Okay? Negative 2 times 6 is negative 12. So when I simplify, I'm going to have negative 4x minus 12 equals negative 12. Okay, now from here, I want to get this 12 on the other side to get 4x by itself, so I'm going to add 12 to both sides. And this is where it can be a little bit frightening, but 0 is an answer. Okay, negative 12 plus 12, those are also additive inverses, so those are going to cancel. And I end up with negative 4x equals 0. Okay, very often I see people solve this and go, oh, well, it's no solution because they can't equal 0. But it can. Okay, negative 4 times some number equals 0 just means it has to be 0. Because if I divide negative 4 on both sides, 0 divided by negative 4 is 0. Or another way to think of it is negative 4 times 0 has to equal 0. So this is going to be x equals 0. So in terms of your solution, this is going to be the point. So these two lines intersect at the point 0, negative 6. For the next one, this one was a little bit more challenging because we don't have the additive inverses already set up for us. Okay, we have negative 4x and an x, and we have 9y and negative 3y. Since those aren't already additive inverses, we have to create them. The way that we create them is by multiplying an entire equation by whatever we want it to be. So let's say, for example, we're getting rid of our x's here. Well, I want this x to be a positive 4x so that I can add these equations together and those will be the additive inverses. So to get x to be 4x, I'm going to take this entire equation and I'm going to multiply it by 4. Okay, when I multiply this whole equation by 4, 4 times x is 4x. 4 times negative 3y is negative 12y. And 4 times negative 6 is negative 24. And then I'm just going to copy this equation on top of it so that we have them stacked up nicely. Plus 9y equals, wow, maybe not nicely. Okay, so now the next process, or the next step for solving by elimination, we're going to add these equations together. Now that we've created the additive inverses, negative 4x and positive 4x are going to eliminate, which is what we want. And then we're going to move on to our y's. 9y minus 12y, or plus negative 12y, however you want to think about it, is going to be negative 3y. And then 9 minus 24 is negative 15. I'm going to divide both sides by negative 3. And when I do that, those 3's are going to cancel and leave me with y equals 5. Just like we did in the problem before, we're going to take that y equals 5 and we're going to plug it back in. This time, let's plug it into the second equation because we plugged it into the first in the other one. Just to show you, it can go into either equation when you're plugging it back in. Okay, when I'm plugging this one in, I have x minus 3 times 5 equals negative 6. Well, negative 3 times 5 is negative 15. Whoa, that's a 6. Whee! Now to get x by itself, I'm going to add 15 to both sides. Okay, from here, those 15s are going to cancel, leaves me with x. And 15 and negative 6 is 9. Yay! So now again, those two equations are going to intersect at the point 9, 5. Sorry, my 9 kind of looks like a Q. Whoa, 9, 5.